Hi guys, my name is Terry. In this video, I'm going to go through the Additional Mathematics SPM Trial paper for the year 2021, like for SBP, Scholar of Asrama Penuh, for paper 2. Now, let's get straight to the first question. So here we have a straight line that intersect, straight line x minus 2y that intersect x minus 2y equals 3 that intersect y equals to k at point A and B. Now, this is Form 4, Chapter 7, Coordinate Geometry. So you're supposed to find the value of k and the coordinate of point A, area, as well as area triangle ABC. So number one, we can see that if this is right angle, we know we have to use m1 dot m2 equals -1, right? And two lines are perpendicular to each other, the gradient must be multiplied together, must be -1. And you can see this line AC is a horizontal line with the equation of y equals to k, meaning the coordinate of point C is now 0. Okay, yeah. When you have a horizontal line that is y equals to 3, that means your y coordinate is 3. Yeah. In this case, y equals k, the y coordinate is just k, and at y-axis, your x value is just 0. So you know point C, but I need to know the coordinate of point B. So what we can do from here is that we can change this equation. We can find the x-intercept for this equation. We know at x-axis, your y value is 0, then my x value should be 3, meaning the coordinate of point B is 3, 0. Right, this will be ugly. Let me fix this, 0 here. Now, this coordinate is 3, 0. And we can see that these two lines are perpendicular to each other. So yeah, we need to do m1 dot m2 equals to -1. But first, let's find out what is the gradient of this straight line. We can find the gradient by changing it into y equals to mx plus c. So let's bring the 2y over, bring the 3 to the left. So you get 2y equals to x minus 3. Your y is 1 over 2x minus 3 over 2. So the gradient of line AB is now half. At the same time, we can find gradient of line BC by using negative y-intercept over x-intercept. My y-intercept is k, my x-intercept is 3, so it's negative k over 3. And we know, because they're perpendicular, this line and this line multiply together, the gradient multiply together must be -1. We can cancel negative. This 3 times 2 is 6, multiply over k is just 6. Okay, so first part isn't too difficult. Now, the next part, part B, I want to find the coordinate of point A. So A is the intersection between this line AC and line BC. Now that I know K is 6, so that means your Y is now 6. So what we want to do is we want to put Y equals to 6 inside here, right? When Y is 6, find out your X coordinate. Your X minus 2 times 6 is now 3. Bring over X is 15. Therefore, your A is 15, 6. Yeah, we write X first, followed by Y. Your X is 15. Your Y is 6. Okay, how about area of triangle? Area of triangle ABC. I know the coordinate point A. This is now 15, 6. I know point B, I know point C. Since my K is 6, so we can just say 0, 6. Right. Now, I know a lot of people would use the formula for area triangle. You can. I'll show you both ways. I have another easier way. A lot of people will say, okay, A, B, C, I'll just use half x1, y1. Let's say A first, right? 15, 6, x2, y2, 3, 0, x3, y3, 0, 6. Repeat point number 1. Yeah, you can do that. Huh? So let's multiply downwards. This is 0. This is 18, right? This is 0. Then you multiply upwards. This is a negative. I have to put a negative in front. 6 times 3 is 18. 0 times 0 is 0. This is 90. 6 times 15 is 90. So we have half of -90. Now we always treat it as a positive because when you use clockwise direction, whatever you're getting is negative. When you use anti-clockwise direction, whatever you're getting is positive. It doesn't matter because area is always positive. So your answer is 45 square unit. Now, another thing is, since this is a triangle and this is perpendicular, look at this. This is your horizontal line. Well, if this is 15, meaning the length from here to here is 15. And we know this is 6, right? Because the value of k is 6. So why don't we use half times base times height, which is so much easier? Your base is 15, your height is 6. We cancel this, 3. 15 times 3, 45. Yeah, you notice the second method is a lot easier. Yeah, it's not necessary to use this shoestring method, you're going to call it, right? It's much easier to use this half times space times height, since we know 15 and 6 are perpendicular to each other. Yeah, but using half times space times height, you get this answer right away. Okay, moving on. This is question number 2. It is for chapter 8 vectors. So here we are given vector u and v, coordinate of point R and S. They are given as -3, 4, and 5, 2. And also RS is HU plus KB. You're given vector UV, you're given a coordinate. So I think we can just sub inside. Now, first of all, I hope you know by now, if you see vector RS, we can say is OS minus OR straight away. For those who are not sure, let me just explain to you very quickly. If this is point R, this is point S. If I want to go from R to S, I can go from R to O, O to S. And OR is just negative of RO, or RO is negative of OR. You plus with OS, put OS in front, RO at the back. So it's always the second letter respect to the first one. It's always, if I give you RS, it's OS minus OR. If I give you AB, is OB minus OA. Yeah, that's always the case. So I hope you are okay with this, because I'm going to use this relation straight away when I form this equation. Okay, starting from here, your RS, I'm going to write, starting from this equation, RS, I'm going to write OS minus OR, and is now HU. My vector U is I plus 5J. Now, for me, I wouldn't like to write in IJ form, because column vector is a lot more easier, and you don't have to underline it, you don't write I and underline it. So I like to write 1, 5 to represent vector U. And I plus with K, your V is 2 minus 4. Yeah, this is vector V. Yeah, instead of writing IJ form, we write in column vector. It's perfectly all right to write in column vector, unless the question asks you to give your answer in IJ form. Right? In this case, no, the question didn't mention. In fact, you're finding H and K, which is not related to whether you write in IJ form, you write in column vector form, it's the same. Okay, my OS is this coordinate -3, 4. Yeah, sorry, this is your OR. This is your OS. Okay, so I'm going to write OS first, which is 5, 2. My OR -3, 4. And I'm going to multiply the H inside straight away. H times 1 is H. Immediately, okay, I do a bit slower. This is 5H. This is 2K minus 4K. I think better write step by step. Step 2, we combine this 5 minus -3 is just 8. 2 minus 4, -2. And this is H plus 2K, 5H minus 4K. All right. So here we can form two equations and solve it simultaneously. Yeah? So let's start by comparing your I component, H plus 2K equals to 8. All right. You can choose to use substitution or elimination, up to you. So here I thought I can see that I got a single H here with a coefficient of 1. Maybe I just bring over, make H as a subject. 8 minus 2K, first equation. Then I look at vector J, the J component. Your H, 5H minus 4K is now -2. This is your second equation. So let's sub equation 1 inside equation 2. The moment I sub inside this 8 minus 2K, U minus 4K, the result is -2. Let us expand this. 5 times 8 is 40. This is minus 10K minus 4K equals -2. Okay, minus 10 minus 4 is minus 14. And I'm going to bring the 40 over. -2 minus 40 is minus 42. 42 divided by 14. There's a negative. Can cancel out. K is just 3. Okay, now this is part A. And then you need to also find your H. I sub inside equation 1. My H is 8 minus 2 times 3. Answer H is 2. Okay, not difficult. All right, next one. Let's find unit vector in the direction of RS. Okay, now that I know RS, actually your RS is this. This is your RS here. This one. Yeah. To find unit vector, I have two different ways to show you. Now, a lot of people would just use the standard method. That is, they say RS, the unit vector. Let's find the magnitude first. The magnitude of RS will be 8 square plus minus 2 square root. So this is square root of 64 plus 4 square root 68. Now, your unit vector, you can use any symbol. You can write, say, UV if you like unit vector, or you can just use another symbol with a cap. You can say, oh, my unit vector is A, and you put a cap. Also can, up to you. So I just write here unit vector, okay, equals, unit vector is defined as a vector with that can move in any direction with a magnitude of 1. Well, here the magnitude is square root 68. To get a magnitude of 1, I basically take this vector, I divide by its magnitude. By doing so, I will get a magnitude of 1. Like, for example, this vector may go this direction. This is 8 to the right, minus 2 down. Okay, so 8 to the right, minus 2 down. So this is a vector in the direction of RS. Okay, but if I want to find unit vector, I want to find what is 1 unit of this. Yeah, now we know this is the magnitude is 6 square root 68, which is 8 point something, right? So you just divide into 8 point something parts. So one part of it is your unit vector. Okay, so we will just take this and divide. But however, notice one thing, when you use this to solve it, right? Your vector can be simplified further, because you learn in Surds, right? If you take square root 68, this is not a simplest form. Square root 68 is 2 Surds 17. Yeah, 68 is 4 times 17. You want, you can write like this. It is square root 4 times 17, right? And then at the same time, this vector 8 minus 2, right? You can actually factorize the 2, 4 minus 1. Okay, so this will give us 2 over, this is 17 here, 2 17, 4 minus 1. As I simplify, I get 1 over 17, 4 minus 1. Now, for me, I don't like to use this because, number one, it's very, very long. And sometimes some of us, we tend to forget to simplify this to the lowest term. So for me, if I can see that my RS has a common factor, like 8 and minus 2, you can see here, your common factor is 2. We'll just take out 2, 4 minus 1. Rather than finding the unit vector for the whole of RS, I just find unit vector of 4 minus 1. Now, after all, when two vectors are going in the same direction, right, they actually share the same unit vector. For example, this is the vector just now. It has a magnitude of square root 68. Now, if I take 4 minus 1, 4 square minus 1 square root. Okay, maybe I write here. 4 square plus minus 1 square root. This is square root 17. Well, it is a shorter vector, right? But if I divide them, like for example, whatever vector I have here, I divide by square root 68, I get my unit vector. Unit vector is 1 unit going this direction. Versus this vector here going in the same direction, I divide by square root 17, I get 1 unit of it going this direction. They are actually the same vector, right? When two vectors are parallel, the unit vectors are the same. So for me, I would say the unit vector, I will straight away take 1 over 17 square root, multiply with 4 minus 1. That's it. A lot easier. So you factorize first, then you find unit vector for 4 minus 1. You are getting the same answer. Okay. Now, again, just so you know, if you don't want to write in column vector, you want to say, I want to write 4i minus j divided square root 17. You can do that, right? So either write in ij form or column vector, doesn't matter, unless the question mentioned, okay, leave your answer in I and j form. Yeah, if they don't mention, it's okay to leave it in column vector. Okay, next question, question number 3. This is from 5, chapter 2, differentiation. Okay, so first you're given equation of the curve y equals x squared over 1 minus x, and the curve passes through point Q. Find the gradient of the curve at point Q. So when we have a curve, it doesn't matter how it looks like, yeah? A line that touches a curve at one point is called a tangent. So the gradient of a curve is actually the gradient of tangent. So in this case, what we need to do is to differentiate this function to find your dy dx and substitute x with -1 to find the gradient at point Q. Okay, step 1, let's differentiate that dy dx. And remember, this is in the form of, we call it we call it a rational function. Yeah, we have to use quotient rule. This is your u, this is your v. When you differentiate, is v u prime minus u v prime over v squared. Okay, by the way, if my u is x squared, my u prime is 2x. Yeah, when you differentiate x squared, you get 2x. If my v is 1 minus x, my v prime is just -1. Differentiate negative x, you get -1. By the way, differentiate 1, you get 0. So my dy dx will be, copy v first, 1 minus x, u prime, which is 2x, minus u, which is x squared, differentiate v, -1, divide by my v, 1 minus x squared. Now, actually, for this question, you don't have to simplify. Some people expand, simplify, and substitute. You don't have to, because we want to find the gradient when x is -1. So we can immediately substitute -1 inside. Okay, don't need to simplify. 1 minus -1, I'm going to write +1. 2 times -1, I'm going to write -2. -1 squared, I write 1. This is -1, I square it, I'll just write 1 straight away. And this is 1 minus -1, 1 plus 1. So you have 2 times -2, which is -4. -4 plus 1, this gives us -3. Your denominator is 2, 2 squared is 4, -3/4. Right? So this represents the gradient of tangent. The gradient of curve at a point is a gradient of tangent. In this case, -3/4. Okay, next I'm finding the equation of tangent to the curve at point Q. Very simple. To find equation of tangent, normally we use this formula, y minus y1, mx minus x1. This represents the equation of a straight line. Yeah. I would do y minus my y1. Let's take coordinate point Q, which is 1/2. Your gradient of tangent, -3/4. My x1 in this case is -1. Minus, I put a +1. So let us multiply everybody by 4, get rid of the fraction. So 4y minus 2. When you times with 4 here, you cancel, left with -2. This is -3. You times in 1 by 1. Minus 3x minus 3. My 4y is minus 3x minus 1. Okay, you can leave it in any form. It's not that you have to leave it in general form or gradient form, or even any specific form. So I'll leave it like this, or if you want, you can divide by 4 and write this as -3/4x minus 1/4. Okay. Question number 4. So this is Form 4, Chapter 3, System of Equation. So one Melissa loves to have breakfast at Retro Coffee with her family and friends on Monday. One Melissa and her husband pay 25 ringgit 50 cents for 2 cups of coffee, a donut, and a tip. All right. On the next day, she and her friend paid 55 ringgit, 4 cups of coffee, 5 donut, and a tip. On weekend, she visited a restaurant with her family, spent 66.70 for 5 cups of coffee, 6 donut, and a tip. So you notice there are 3 variables here, which is your coffee. Okay, I'm going to call it X, donut, I'm going to call it Y, and the tip, I'm going to call it Z. Now, here's the thing. They say she always gives the same amount of tip every time. Yeah, same amount of tip every time she visits the restaurant. So yeah, you want to find the price for a cup of coffee, donut, and a tip. So number 1, the first equation is when she went there with her husband, right? She bought 2 cups of coffee, a donut, and a tip. So we say 2x plus 2y, 1y plus z equals the amount that she paid is 25 ringgit 20 cents. Okay, that would be my first equation. The second time she went there, she went with her friends. She paid 55 ringgit for 4 cups of coffee, 5 donut, and a tip. So 4x, 5y, and z, and she paid a total of 55 ringgit. 55. Equation number 2. Okay, so the third equation will be she went there with her family. She bought 5 cups of coffee, 6 donut, and a tip. Total 66 ringgit 70 cent. Equation number 3. Okay, So the question is, how do we solve this? Now, the way I look at it is it has all these three equations. They have the same coefficient of z. So I think it's easy to use elimination. As we subtract, we can get rid of z quite easily, right? You may want to start off with, let's say, equation 2 minus equation 1. Yeah. Now, picture this. If you take 4x, you minus 2x, you're left with 2x. If you take 5y, you minus with y. Yeah, 5y minus with y, you're left with 2y. And the z, you subtract with z, that z disappear. And 55, you minus 25, 20, you get 29 ringgit and 80 cents. Now, you can't do it mentally. Just use your calculator. 55 minus 25, 20. Here you go. 2980. Okay, so that is your before we call this equation 2, I look at it, maybe I can divide by 2, make the number smaller, right? Because all these are divisible by 2. X plus y is now, okay, 30 divided 2 is 15, right? So 2980 divided 2 is 1490. You can't do mentally, use calculator, divide by 2, there you go, 1490. I'm going to call this equation number 4. Okay, I still need to get rid of equation the z from equation 3. Maybe you can do 3 minus 2, you can do 3 minus 1. But I think perhaps 3 minus 2 is easier. 3 minus 2. When I do 3 minus 2, 5x minus 4x, left with just x. All right. And then 6y minus 5y. 6y minus 5y is just y. Okay. Okay, I think I made a mistake. The first one, 5y minus 1y. Sorry, this is 4y. I made a mistake here. This is 4y. 5y minus 4, 1y is 4y. So this is 2y. Sorry for that. Okay, 5y minus 4y is just, minus 1y is 4y. When you divide by 2, I got 2y. Then equation 3 minus equation 2, 6y minus 1y is just y. 6670 minus 55 is 11 ringgit 70 cents. So you notice if I divide by 2 earlier in equation 4, I can actually simplify this. And I got x plus 2y. This one I got x plus y from equation 5. So let's just take equation 4 minus equation 5. And we will be able to get rid of x. X minus x disappear. 2y minus 1y is y. 1490 minus 1170 is 3 ringgit 20 cents. So the price of a donut is 320. Okay. Now, next, I need to find the price of a cup of coffee. So I'll just sub inside equation 5. My x plus 3 ringgit 20 cents is 1170. So 11 minus 8 minus 3 is 8. 70 minus 20 is 50. The cup of coffee is priced at 8 ringgit and 50 cents. Okay, I still need to find the tip, how much she paid for the tips, okay? So we sub inside equation 1. Yeah, you can use any equation, but equation 1 has a smallest coefficient. So your x is 850, your y is 320, plus z is 25 ringgit 20 cents. Okay, so this is 17. You can use a calculator. 2 times 850 is 17, actually. Then you plus with 3 ringgit and 20 cents. Okay, let me just work it out one by one. This is 20 ringgit and 20 cents. You plus with z, you get 25 ringgit 20 cents. So take 25.20 minus 20.20. The tips amount that she paid is 5 ringgit. Okay. Okay, question number 5. This is question on Form 4 Chapter 5 progression. So it's given that A is a first term, R is a common ratio of geometric progression. Show that the sum of the first n term of this progression is given by this formula. Okay, so this is a little bit more difficult, I would say, because you have to derive the formula, right? So number 1, we know that your sum of the first n term is given by A, AR, AR square, and so on. It's up to you. You can write as many as possible. I'm just going to write the first 3 and the last 2 for your reference. Okay. Now, remember, the last term, Tn, is given by ARn minus 1. So the second last term will be ARn minus 1 minus 1. that gives us ARN minus 2. That's why I wrote this as ARN minus 2. Okay, in order to derive this formula, I need to get rid of all the sum in between. So I would take equation 1 multiplied by R. I get R as N. Okay, let me squeeze in here. This is 1 times R. This is R as N. A times R will be AR. AR times R is AR squared. AR squared times R is AR cubed. And the second last term is ARN minus 1. Now, how do you get minus 1? This is minus 2, right? If you multiply by R power 1 is minus 2 plus 1, which gives us N minus 1. And of course, the last term, if you minus 1, if you have R power N minus 1, you multiply R power 1, you get minus 1 plus 1, which is R power N. Yeah, AR power N. All right, I've got the second equation. Okay, the next thing I need to do is to take equation 1 minus equation 2. So normally we can do 2 minus 1 or even 1 minus 2. But in this case, I have to do 1 minus 2 because you can see your final answer is 1 minus R. So the R must come last. Okay, so we take 1 minus 2, your Sn minus R Sn. Now here's the magical part. So when you subtract, what happened? This A has nothing to cancel, to subtract, but AR, we cancel with this AR. This AR square will cancel with this AR square. Now the next term is going to be AR cubed. It's going to cancel with this one, right? And the second last term of the first equation, AR power N minus 1, will cancel with the term before this. ARN minus 1 will cancel with the term here, right? The second last term for the second equation. Now what is left is the first term of the first equation and the last term from the second equation. So we are left with A minus AR power N. So we can factorize here. I'm going to take out Sn, 1 minus R, right? And I'm going to take out A, 1 minus R power N. And when I divide them, I get A, 1 minus R power N, 1 minus R. There you go. I have derived this formula here already. Okay, next. Part B. Given that the common ratio of this geometric progression is 1/3 the sum of the first 14 term. Yeah, sum of the 14 term is the common ratio is 1/3 and the sum of the 14th term is 6.75. Using the formula given, find the first term of the progression. Okay, so I know my S14 is 6.75. My A is an unknown. My R is 1/3. So I substitute 14 inside. Divide by 1 minus 1/3. The result is 6.75. Okay, now let's use our calculator. I'll leave it here. This is bracket 1 minus 1/3. So please put the open bracket 1/3, close bracket power 14, divide 1 minus 1/3. Okay, so whatever I get here, 1.49999, I take 6.75, divide answer. Okay, my A is approximately 4.5, 4.5000. I will just take 4.5, or you can write 4.50. Yeah, no problem. In fact, it's 4.500, but if all the 0 here, you don't have to write the 0. It doesn't matter, right? Okay, or you can just write 4.5. Now, C, hence find the sum to infinity. Okay, this question is a bit interesting because they give us S14. S14, when your n is large, right? Your R power n approaches 0. Yeah, so we know sum to infinity is given by A divided by 1 minus R. So my A is 4.5, my R is 1/3. So when you divide this as 4.5 divided by, okay, should I use this? 1 minus 1/3. Now you realize that this answer is actually the same as 6.75. Yeah, S14, 6.75, but it's okay. You can write 27/4, all right? Or if you write 6.75, it's still okay, right? Now, why do we get the same answer? Because when your n is 14, it's a big value. Yeah, if they give you n equals to 3, n equals to 4, then, or even 5, it doesn't matter. Your sum will not be the same as your sum to infinity. But when your n is large, right, the sum of first 14 term now is very close to sum to infinity. In this case, it is the same as your sum to infinity. Yeah, another thing is, of course, we rounded off the value of A earlier. A just now is supposed to be 4.5000 with a number, right? We just take 4.5. That's why, yeah, it's the same. Your sum to infinity is the same as sum of the first 14 terms. Okay, moving on. This is question number 6, Form 5, Chapter 6, Trigonometric function. Okay, so the first part is a proving question. Prove that cosecant square minus 2 cos square minus cotangent square equals to negative cos 2x. Okay, so let's start off with the left-hand side. Normally, we start from the side with more number of terms. Your cosecant, okay, now at this stage, sometimes you don't know what to do. Or maybe I list out for you the formula, the basic identity. There are 3 basic identity formula. The first one, of course, is cos square plus sine square is 1. Yeah. The second one, if you divide by cos square, you get 1 plus tangent square equals to secant square, right? So I can't use the first one. I can't use the second one because there's no cosecant. I mean, there's no secant. There's no cos and sine. And the third one, I divide by cos. I divide by sine. I get cotangent square x plus 1 equals to cosecant square. So in this case, you can see I have to use the third formula. So starting from here, I'm going to replace my cosecant with cotangent square x plus 1. Then I minus 2 cos square x minus cotangent square x. Now that cotangent and cotangent you can cancel, right? Now you're left with 1 minus 2 cos square x. Okay, here's the thing. Even cos 2x has 3 formula. The double angle formula for cos. Yeah, in case you cannot remember, I'm going to write down for you. Cos 2x, the 3 formula. And all these formula are given in exam, the basic identity and the double angle formula. So cos 2x is cos square minus sine square, or 2 cos square x minus 1, or 1 minus 2 sine square x. In this case, we have to use the second one. Now, take note, we can always have a look at the right-hand side. Now, what we have here is negative cos 2x. So I know I have to use this result, right? We want to factorize the negative here. So the 1 becomes negative, minus 2 becomes positive 2, cos square x minus 1. And this is now cos 2x with a negative in front. And it is the same as my right-hand side. Okay? All right, next one. Hence, using the same axis, sketch a suitable straight line to find the number of solution to this equation. Okay, so before you find the number solution to this equation, what I need to do is to use the result. Okay, sorry, I need to sketch a graph first. Sketch a graph and hence find the number solution. Okay, to sketch this graph, okay, first of all, I hope you know how to draw a basic cos graph. Okay, I'm gonna do it here. The basic cos x is like this. It goes down and up. Maximum 1, minimum negative 1 from 0 to 2 pi. But this is cos 2x. Cos 2x means we have to draw 2 cycles, 1 and 2, until 2 pi. Another thing is there's a negative in front, negative cos 2x. So we're going to invert upside down. Instead of starting from 1, I start from negative 1, up, down, 2 cycle until 2 pi. Okay, and notice there's a half in front. So basically, I'm taking this graph and shifting it up by half. So if you want to draw y equals to negative cos half, cos 2x plus half, you are shifting everything up by half. That means 1 plus half is going to be 3 over 2. I'm going to put a 3 over 2 here. All right, I'm going to put a 1 here. I'm going to put 1 over 2 here. And this would be my 0. This is my negative half. Let's draw 8 segment, 3, 4, 5, 6, 7, 8, right? So ideally you use a ruler, yeah, and measure accurately. It will help you to get a better, more balanced graph. Okay, so another thing is that the half here also represent what we call the line of equilibrium. And I always like to draw this line to make sure that my graph is balanced. Okay, I'm going to start from, instead of negative 1, right? I shift up by half. A negative 1 plus half is half. I'm going to start here and I'm going to plot the point 1 here, 2 here, right? 3, Okay, sorry. The second point is not here. The second point is over here. 3, here, 4, 5, 6, 7, 8, and 9. So it should be going up. Okay, maybe I should use a darker pen, darker line, thicker line. Thicker line will help to hide the ugliness. There you go. Down. Okay, this can be improved. Okay, down. This way. Up. This way. Okay, I'm missing the point. Maybe I can go back to this way. Okay. This part can be improved. Can be better. Yeah, I'm a bit of a perfectionist. All right, and lastly, yep, there you go. So this is 2 pi, this is now pi, you subdivide it, right? So this will be pi over 2, if this will be 3 pi over 2. So it actually is not necessary to label all, right? You just label the important one, in this case, the 4 segment here, yeah, that will be sufficient, okay? So, but if you want, you can add in a pi over 4, this is 3 pi over 4, this is 5 pi over 4, and this is 7 pi over 4. Yeah, 7 pi over 4. So basically, when you take 2 pi divided by 8 segment, is pi over 4 each. So you keep adding pi over 4. Yep. Okay. Now, with that, we can now find sketch a straight line. So your straight line, we want to use this result. See this? 2 cos square x minus 2 cos square. Can you see that there's a 2 outside, right? So number 1, okay, I'm going to put, this is B Roman 1, B Roman 2 E over here. Okay, so I'm going to start off by taking the result from the first part. The whole thing equals to negative cos 2x, right? So there's a 2 sitting in front here, 2 sitting in front here. The whole thing here is negative cos 2x, and it's now equals to negative x over pi plus 1. Okay, so now I'm going to divide everybody by 2. As I divide by 2, I get x over 2 pi plus half. Now notice that the equation or the graph that we drawn earlier is half minus cos 2x. So I'm going to plus half on the left and on the right. So when you add by half, this is now 1. So the straight line that we have to draw is this. Yeah, your straight line is y equals negative x over 2 pi plus 1. Okay, for this straight line, what I need to do to draw a straight line is to use 2 points. Here, normally we use the smallest and largest. Smallest being 0, largest is 2 pi. I put a 0 here. I put a 2 pi here. When I substitute 0 inside, I get 1. When I substitute 2 pi inside, I get negative 1 plus 1, which gives us 0. So the coordinate that we have is 0, 1, 2 pi, 0. So I'm going to use a blue color line here. 0, 1 is here. 2 pi, 0 is here. I'm going to draw a straight line. Yeah, just join from here to here. Something like that. I'll move it down. Okay, so your line should be here. Okay, now remember, the number of solution to this equation over here is the number of intersection between the first graph and the second graph. Yeah, yeah, they are equal if they have the same y value and same x value, and your x value is your solution. So what we do is we count the number of intersection. This is 1, 2, 3, and 4. So from the graph, you can see the number of intersection is 4. So your number of solution is just 4. Okay. Okay, question number 7. This is your Form 4, Chapter 4, Indices, Surds, and Logarithm. Okay, So here at the beginning of the year 2020, the population of a species of an animal in a reserve forest estimated at 10,000. Number decreases after, so that after T years, the population is given by this function. Okay, so estimate the population in the beginning of year 2025. Okay, now 2020 is when you start the clock. When T equals to 0, the year was 2020. So in the year 2025, you need to identify what is your T value. Your T value is 2025 minus 2020. The difference is 5 years, right? So after 5 years, we want to find what is the population of the species. Okay, so your N is now 10,000 E negative 0.05 times 5. Okay, use your calculator. 0.05 times 0.03 times 5 is negative 0.15. So we can use your calculator 10,000 here, shift ln to get the E exponential, negative 0.15. And my answer is 8607. Yeah, 8607. That's all. Yeah, very simple. All right, second part. The year in which the population would be expected to decrease to half of the population in the year 2020. Okay, so actually the population is decreasing. So if you were to sketch a graph, actually the graph is like this, decreasing. As you can see, it started off with 10,000. Then it started to decrease. After 5 years, it's only 8,607, right? So it's decreasing until at one time, it would be half of its population. So half of its population would be like 5,000, right? So it's at 5,000. So now let's do this. We put 5,000 inside. This is E, sorry, we start with 10,000. Okay. We put E negative 0.03 T. Now 5,000 divided 10,000 is just half. So E negative 0.03 T is now half. Now remember, you know how to change from logarithm to index form or index form to logarithm form. That is, when I say a power x equals to y, in logarithm form, we say x equals log base ay. It's just that this is in the normal general form, general base. If you have e power x equals to y, we say x is log base ey, and log base e is just ln, so x is ln y. So let's write negative 0.03 t equals to ln half. Yeah. So the thing is, I know a lot of students, you're not familiar with ln. Ln is just log base e. So your t value would be, let's take negative 1 over 0.03 ln 1 over 2. Type this in your calculator, right? Negative 1 over 0.03 multiply with ln 1 over 2, close bracket. There you go. 23.1. Yeah, 23.1. Now, here's the thing. This question is not an inequality. It is not that the minimum, if the question say the minimum number of years such that the species decreases to less than half, then we have to use inequality. No, this one we just estimate. Yeah. Yep. So in this case, we can say it's approximately 23 years. It's okay to just use estimation. Okay. So what is the year? Well, we started from the year 2020. You plus 23 years, so it's 2043. Yeah, the year will be 2043. Okay, so this is only the first part. Then we have second part. First part is this is a combination of indices with logarithm. The second part is related to surds. Okay, so here we have two congruent triangle ABC and PQR, right? And you're supposed to find the length of x in the form of a plus b surd c. Okay, we know when two triangles are congruent, the corresponding angle the corresponding length of side, if you compare, it must be proportional. For example, if I want to find x, right, we say the ratio of x divide by, you can take x compare with surd 3. The ratio must be the same as surd 12 plus 2. You compare or divide by surd 12 minus 2. Okay, so now what we can do is, okay, maybe I can multiply but surd 3 over. At the same time, I'm going to rationalize the denominator. Now, when we say rationalize the denominator, you're multiplying top and bottom with the conjugate of this. Now, this 12, surd 12 minus 2, right, is conjugate is surd 12 plus 2. It's like a twin sister. One is a plus, one is a minus, yeah, twin brother or sister. So you need to multiply with its conjugate, square root 12 plus 2 and square root 12 plus 2. Okay, so when you do that, okay, I like to put this together first. And now it looks like this. This is surd 3, surd 12 plus 2 with a square, right? So because this is in the form of a plus b square, whereas my denominator is in the form of a plus b, a minus b. Yeah? Now, the very reason why we multiply with this conjugate is so that when you expand this, you get a square minus b square. In this case, your a is surd 12. When you square it, it's 12. 2 square, when you square it, is 4. Is surd 12 square minus 2 square. Yeah, so I just write 12 and 4. Okay, now for your numerator, I like to expand using this a square plus 2ab plus b square. My a is surd 12. Surd 12, when you square it, is just 12. The middle term is 2 times surd 12, which is 4 surd 12. And last term, 2 square gives us 4. My denominator is 8. Okay, next, let's keep the surd 3 here. 12 plus 6 plus 4 is 16. Keep the 4 surd 12 divided by 8. Okay, now I think we can still simplify this. So I'm going to multiply this surd 3 inside 1 by 1. So when you times in, right, this will be 16 surd 3. And surd 3 times surd 12 is surd 3 times 12. Keep the 4 in front. Keep the 4 in front. This is 4 surd 3 times 12. Can I write 36? 3 times 12 is 36. And square root of 36 is 9, right? 9 times 4 is, square root of 36 is 6. 6 times 4 is 24. 24 divided by 8. This will be 2 surd 3 plus 3. Okay, since the question asks us to leave our answer in this format, so I'm going to put your constant in front, 3, or should I say the rational number in front and the irrational part at the back. Yeah, the irrational part is the one with surd at the back. So we leave our answer in this form. Yeah, a plus b surd 3. So its answer is 3 plus 2 surd 3. Okay, let's move on to question 8. This is section B, first question, question 8. So here we have a straight line y equals to x minus 1 that touches the curve y squared equals to 4x minus 8 at point A. So find the coordinate point A. Okay, so first part, you want to find the point of intersection. Yeah, we have to call this equation 1, call this equation 2. Maybe I sub equation 1 inside equation 2. Right? So we can get rid of your y. Your y is now x minus 1. You square it, you get 4x minus 8. So let's expand this x squared. Okay, this is part A. X squared minus 2x plus 1 equals 4x minus 8. Let's rearrange it. Bring the 4 to the left. 6x plus 9 equals 0. So the good news is we can actually factorize directly. This is a squared plus 2ab plus b squared. When you factorize it, you get a plus b bracket squared. So you notice the first and the last term are a perfect square term. So this is x. The last one is 9. 9 square root is 3. Since the middle term is negative, so I put the negative in, in the middle here. So your x is 3. Yeah, there's only one answer. X equals to 3. Yeah, there you go. X equals to 3. Okay. I need to find y as well. Coordinate means find x and find y. I sub inside equation 1. My y is now 3 minus 1, which gives us 2. Therefore, your coordinate point A is 3, 2. Okay, so that's 3, this is 2. Okay, how do you find area of the shaded region? Okay, for me, before you find area of shaded region, you could identify where is the area. I can see that in this case, let me highlight for you. This is a triangle, right? I need to minus this area. Okay, triangle minus integration. Okay, but having said that, right, some student may say, why don't we take this curve, right, minus this trapezium? You can also, you will still get the same answer. But in this case, you'll be integrating respect to y because I'm integrating this direction here, right? So either way also can, but I think it's easier to find by integrating respect to x, right? Rather than integrating respect to y. But the difference is when you integrate respect to x, you need to make y as a subject. Your y in this case is square root 4x minus 8. Yeah, you need to make y as a subject, then only you integrate. Okay, so let me use area triangle. Now we know that triangle, in this case, I also know this is 1. Okay, maybe I write here. Now we know at x-axis, your y is 0. So from this equation, x minus 1 is 0, x is 1. So this is 1, okay? So if you're finding area of a shaded region, I will take area of triangle minus integration. My area of triangle is half times base times height. My base, if you measure from here to here, is 2. 3 minus 1 is 2. Your height is also 2. So it's half times 2 times 2. Then you minus area of integration. Yeah. This part here, you've got to integrate. By the way, I also need to find this. This one. Okay, we say at x-axis y 0. That's from equation 1. This is from equation 1. But if you take equation 2, your y is now 0. Your 4x is now 8x is 2. So this one is 2. That means I have to integrate from 2 to 3. And your function y, in this case, is 4x minus 8 to the power of half dx. Yeah, I use integration of y dx. Y dx means from here, you move down towards the x-axis. Yeah, dx represent x-axis. Okay, so let's just solve this. This will be 2. Now, when you integrate with a bracket, this is a composite function. I hope you remember ax plus b to the power of n. When you integrate, you copy the bracket, increase the power by 1, divide by the increased power, and always differentiate inside the bracket. Inside the bracket, there's a differentiate ax, you write a below here. So in this case, my bracket is 4x minus 8. Increase the power by 1. 1 over 2 plus 1 is 3 over 2. Divide by the increased power, 3 over 2. Differentiate inside 4. Lower limit 2, upper limit 3. So let's simplify further. All right. I'm going to start off by putting, copy the 2 first. Okay, before I put the 3 inside, this one you can cancel. Cancel that with 2. I'm left with 1 over 6. Okay, let's put 3 inside. You get 4 times 3 minus 8. Actually, we can write this 4 times 3 is just 12. 12 minus 8, you can just write 4. Okay, maybe I write 4 straight away. I hope this is okay. Or, okay, I tell you what, I write one extra step. It's easier. All right, this is easier for you guys to understand. This is 4 times 2 minus 8, power 3 over 2. And this will give us 2 minus 1 over 6. This is 2. 4 minus 4 times 3 is 12. 12 minus 8 is 4. 4. If I square it, it's 2. 2 power 3 is 8, right? But this is just going to be 0. Okay, if you can't do it mentally, you can use a calculator. This is 4 power 3 over 2. There you go, it's 8. Yeah, the other one is 8 minus 8, which is 0. So basically, we take 2 minus 8 over 6. 8 over 6 is 4 over 3. Guys, my answer is 2 over 3. Okay, of course, you can use your calculator to double check your answer. Just type this integrate, right? Your original function is 4 alpha x. X is over here, alpha x. You minus 8, close bracket, power 1 over 2. My lower limit is 2. Upper limit is 3. You should get 8 over 6 or 4 over 3. Yeah, 4 over 3. Well, the calculator takes some time to do it. All right, 1.33 is 4 over 3. Yeah, 4 over 3. Yeah. Okay, then you take 2 minus answer. Of course, you will get 0.6667 or 2 over 3. But please use the exact value and don't use decimal point. Okay, this is part B. Let's move on, part C. Volume of revolution in terms of pi. Yeah, when the shaded region is revolved 360 about the x-axis. Okay, when you rotate 360 about x-axis, I hope you know that when you have a triangle, when you rotate 360, okay, this one's supposed to be touching. We draw a mirror image of it. We rotate this shape. We're getting a cone. A triangle, when you rotate, you're getting a cone. But this is a cone that you need to subtract this curve here, right? And when you rotate, okay, first of all, we already know this is 1. This one is 2. This is 3. We know the height here just now, it was 2, right? Okay, so this cone has a radius of 2 and the height of 2 as well, right? So this is 2, this is 2. So we can say the volume will be the cone minus integration. The formula for volume of cone is 1/3 pi r squared h. My r is 2, I square it, my h also 2. Then you subtract integration pi y squared dx. I remember when you rotate about y-axis is x squared dy, x-axis is y squared dx. Okay, my y square is already 4x minus 8. So you don't have to square it anymore. It's already squared, all right? And the lower limit is 2, upper limit is 3. Okay, so let us just simplify this. 2 squared is 4, 4 times 2 is 8, 8/3 pi. For the second one, I'll take out the pi. Now, you can choose to integrate individually, as in this is 2x squared minus 8x. You can choose to do that, right? Now, personally, I like to use composite function because for me, composite function is easier. And again, it's up to you. You can take out the 4. Okay, I take out 4 here before I use composite function. I take out, factorize the 4 pi. This is going to give us 2 to 3, x minus 2. All right, I do it this way. You can integrate 1 by 1. This 8/3 pi, there's a 4 pi here. When I use composite function, I increase the power by 1. This function here, composite function, right? Increase the power by 1. Divide by the increased power, differentiate inside. Since this is 1x, differentiate is still 1. I don't have to write. From 2 to 3. Now let's cancel 4 pi and 2. This is 2 pi. Substitute 3 inside. 3 minus 2. 2 minus 2. 2 minus 2 is going to give us 0. So this is going to give us 8/3 pi minus 2 pi. Final answer, 2/3 pi unit cube. Yeah. Okay, again, now you can use your calculator to double check. You can integrate 4 alpha x minus 8 here, lower limit 2, upper limit 3, just press equals, you should get 2. Yeah, see, it's 2 over here, just add a pi. So 8/3 minus 2, I got 2/3. Okay. Okay, moving on, this is question number 9. This is from 4, chapter 6, linear law. Okay, so the first thing I'll do is I will have to draw a table values. Now it's given the table shows a variable of 2 variable x and y from an experiment. They are related by this equation. Y equals ax plus 1 power b, where a be a constant. So based on table, we could build table values for log 10 x plus 1 and log y. So log 10 x plus 1 means you take the x value, you plus 1, then you take the logarithm. So I'm going to write over here log LG means log base 10 x plus 1. So the first part, I'm going to take log, so 1 x plus 1, in this case 0.32 plus 1, so it's 1.32, 0.12. Yeah, this is 0.12. Now the second one, I'm going to take 0.86 plus 1, 1.86. Okay, so this is 0.27. Okay, next one, 1.19, you plus 1 is 2.19. 2.19, I got 0.34. Next one, a 1.57 plus 1, 2.57, 2.57, 0.41. Next one, 2.16 plus 1, 3.16. Yeah, 3.16. Okay, I got 0.4996, 4997. I'll round off to 0.50. And lastly, we take log 3 3.27 plus 1 is 4.27. Okay, so I got 0.63, yeah? 0.63. Okay, so I've got my log x plus 1 done. Let's do our log y. So this one will be, let's start off with log 2.57. I got 0.41. Yeah, 2 decimal point will do. I don't have to put too many. Next one is log 5.89. I got 0.77. Log 8.71. 0.94. Let me squeeze in here 0.94. Next one, log 12.3. 1.09. Next one, log 20.89. 1.32. Lastly, log 41.69. I got 1.62 as well. Okay, so I've got my log y, I got my log x plus 1. Okay, so the next thing is this. I need to plot log base 10y versus log base 10x plus 1. Okay, so now on here's the thing, you can use one method to validate your answer. Okay, so that is if you have this calculator, I'll show you this one. You can go to mode, go to 3 for stats, 2 for a plus bx, key in your x value. In this case, your x value is 0.12, 0.27, all right, 0.34, all right, 0.41, next one 0.5, next one 0.63, right? And then move on to your y value. This is 0.41, 0.77, 0.94, 1.09, 1.32, and 1.62. So I've got all my x and y value key in, right? Then you go to mode, you go to 3 for stats, all right? Okay, wait. Shift 1 for stats. You go to, okay, where is my value? Shift stats. You should go to, my data is still there. Oh, okay, I'm sorry, I accidentally clear the data. So you go to, once again, you go to 3 for stats, a plus bx, your x value, oh no, I have to key in again, 0.27, 0.34, okay, 0.41, 0.5, 0.63. You go to your y value, my y value, 0.41, 0.77, 0.94, 1.09, and 1.32. Lastly, 1.62. Okay, so once you key in everything, you go to AC first, shift 1 for stats, go to 5 for regression. 5 for regression. So you got your A, B, R. Your A represent your y-intercept, B is your gradient. So I press 1, I press equals. Yeah, my y-intercept 0.127 or 0.13. Yeah, so I'll just take 0.13. So I know my y-intercept is going to be 0.13. And my gradient, I press shift 1 again, press 5 for regression, press 2 for B, I press equals 2.37. That means my gradient is 2.37. Okay, so with that, I know that my answer, if my answer is different, very different from this, so I know something is wrong. Okay, here the question gave us the scale 2 cm to 0.1 unit on the horizontal axis. Oops. 0.1 unit. So let me start from here. 0, 0.1, 0.2, 0.3, 0.4, 0.5, 0.6. My largest is 0.63. So we can go up to 0.7. This is my LG x plus 1. Okay, for my vertical axis, they say use 2 cm to 0.2. So this is 0.2, 0.4, 0.6, 0.8, 1.0, 1.2, 1.4, 1.6. My largest is 1.62. So I think we can do 1.8. Yeah, this is my LGY. Okay, let's plot the point one by one. Okay, first one is 0.12 and 0.41. Okay, 0.41 is half of the smallest box because the smallest box is 0.02. So 1, 2 is over here. So it's like half of it. So around here. Next one, 0.27, 0.77, 0.77, 0.778. This is 78. 77 is between, okay, 0.2 is over here. Between 0.76 and 78, yeah, in between, and 0.2 is here, the vertical. Next one, 0.34 and 0.94. 34 and 94. 94 should be here. 34 is here. You have to see. Okay. 0.34. Okay, I hope I didn't make any mistake here. 0.94, 0.34. One is a bit off here. 3, 4, and 9, 4. 3, 4 is here. So this is a bit off. 0.77. Okay, maybe let's double check. Let's just calculate this. Wonder whether I made a mistake in my calculation. This is 1.86. Let's just double check. 1.86. 0.27 is correct. Log 5.89. Okay. 0.77 is correct. Yeah. But this one is a bit off. 0.77. This is 7. Okay. Okay, my 0.27. I put 0.2, sorry, 0.27. So it's over here. This point. Slightly higher. Yeah. It'll be hard to see. Yeah, this is 0.27. Yeah, sorry, I misread that point. Next one, 0.41, 1.09, 0.41, 1.09. 41, 1.09 is close to 1.1. So it's around here. Okay. Now next, 0.5 and 1.32. 1.3 is here, 1.32. Okay. And lastly, 0.63, 1.62. 63, 1.62. Okay. All right. Okay, but I know my y-intercept is going to be 0.13. 0.13 is here, 0.1413. So this is 0.13. Okay, so I know it's somewhere here. I'm going to draw my line of best fit. Okay, so in a way, you're like cheating method, because we already know our y-intercept is going to be 0.13. You just have to adjust it. Yeah. Okay, my line here is really hard to adjust. Okay, so let me just try again. Okay, this is 0.13. It's very hard to adjust the line. Okay, it's not perfect at all. So I think I have to redraw. Okay, yeah, I had to try again because I couldn't get, unless I use a ruler, yeah, to get my line of best fit. Okay, so let me just try using ruler to adjust it. Okay, the angle. Okay. I think it's easier using this. Yeah, just ignore the ruler. All right, don't want the ruler. Just draw a line of best fit. It's very hard to use the ruler as well. All right, so yeah, I got a nice point here. Yeah, it passes through this point. You can see it doesn't pass through the first point. First point is a bit higher, a bit lower, right? This is 1.3231. 1 point above, 1 point below, 1 point above, 1 point below. I think it's okay. Yeah, I think this is okay, right? Okay, so almost all the points on the line of best fit. Okay, so next we're going to find the gradient. Okay, so I think because on the graph you're going to find A and B. we need to find gradient. So this is 0.13. So 0.13. Let's take 5 horizontal boxes. Why 5? Any number divided by 5 is a nice number. So, okay, this one will be hard to see. I look at it is between 1.31, 1.32. I know it might be a bit lower. I'm going to use 0.5 and 1.31. Okay, 1.31. You can, I think you can use 1.30 as well. Okay, 2 things to need to know from the linear log graph. We need to find the gradient, we need to find the y-intercept, so we can find A and B. Okay, I think I have enough space to do it here. So I will just find out my gradient from here. My gradient will be y2 minus y1, 1.31 minus 0.13 divide 0.5 minus 0. Okay, use your calculator. Right? 1.3. Okay, let me just change this. 1.31 minus 0.13 divide 0.5. Now, I got 2.36, which is very close to my answer. My answer is 2.37. Yeah, I got 2.36. Very close. Huh? So, okay, I got my gradient, I got my y-intercept. Now, how do you find the value of A and B? Okay, so starting from this equation here, your y is now A x plus 1 power b. So we're going to introduce log on both sides of the equation. I'm going to break it up. Lg A plus Lg x plus 1. There's a power b here, right? Bring the power b in front. So, and I'll write this first up. B Lg x plus 1 plus Lg A. This is your Lgy. So this is your big Y. This is your gradient. This is your x and your c. That means from the graph, if you can find your gradient, my gradient is 2.36. Therefore, by comparison, my b is 2.36. Then from the graph, I compare my y-intercept. My y-intercept from equation is Lga. From the graph is 0.13. To find A, we anti-log, or we say shift log. Yeah, 10 power 0.13, you round off 1.349. Yeah, 1.349. Okay, which is very close. My 0.13 here, because I got from my calculator. Yeah, okay. All right. So, yep, I hope this graph is not too difficult for you. Okay, moving on. Question number 10. This is your Form 5, Chapter 5, Probability Distribution. So in the school, a total of 255 students set for year-end examination. Average marks follow this normal distribution with mean of mu, variance of sigma squared. Based on analysis, right, it was found that 3.03 students got an average mark less than 50, and yeah, and 10.56% of students got average mark more than 75. 75, yeah. Determine the value of mu and sigma. Okay, so we will start off by forming 2 equations. So the first equation, you say that 3.03% got average mark less than 50, right? Less than 50. So we know this is 0.0303. Okay, so when you standardize it, this is 50 minus your mu divide standard deviation sigma equals to 0.0303. Now I like to do a rough sketch. So we know that this 50 minus mu over sigma should be on the left, so that the probability that is less than this is 0.0303. Okay, oh, very ugly, 0.0303. Okay, what we need to do is to either use the mathematical table or your calculator. Okay, one moment. Okay, let's look at our mathematical table. 0.0303 to find from here. 0.0303. Slowly find. Now, that's a problem to find inside here. Let me show you. 0.0303 is, you need to pick a number slightly bigger, right? 0.0336. I need a minus 36 because this is subtract. I just subtract 36 for tolak. Yeah, subtract 36 from the last digit, right? 0303. Okay, sorry, this is not the smallest. 0303, I need to go further here. Yeah, I need a 0303. I need to subtract 4. So I go across, there's a 4 here, right? When you subtract 4, you should get, yeah, actually there are 2. You can take the first 4 or the second 4. Both also can, right? So your answer is 1.875, 1.876. So there are two possibilities. But if you want the most accurate answer, you can actually use your calculator. Okay, let me show you now. Okay, 1.874, 1.875, or 1.876. I want to show you how to use this calculator. Only this calculator you can get. You press mode, you go to 7, you go to number 3 for inverse normal. All right, the area is 0.0303. Now I got 1.876. However, take note that this calculator will give a negative answer. It's negative because it is actually measured from the left to the right. Okay, so we just ignore negative. If you use the mathematical table, you either get 1.875 or even 1.876. Both also can. Okay, so from the mathematical table, actually we measure, when you use the mathematical table, it's always based on the upper tail, right? So you need to understand that it's always upper tail. That's why it's always more than. But we can actually flip it over. For example, if you use a table, right? If you read 1.876, you can even use 1.75, right? This is 0.0303. However, you can see this on the left. So you're going to flip it over. So when you flip it over, this 50 minus mu over sigma is now equivalent to negative 1.876. Yeah, it's negative because it's on the left-hand side. So as in you flip this to the left, they are symmetrical. This is 0.303. This is negative 1.876. Okay, let's multiply this up. Negative 1.876 sigma. This is your first equation. Okay, second equation. Based on analysis made, we know that 10.56% of students got average mark made more than 75. Average mark more than 75. So this will be Z more than, okay, so let me write this first. This is 0.1056. So let's standardize this as Z more than 75 minus mu over sigma 0.1056. Okay, 1056, I'm going to read from here. Where is 1056? 1056, yeah, exact value, 1.25. Yeah, nice number, 1.25. Okay, so, or you can use your mathematical table, your calculator, right? You go to 0.1056. Can you see? You also get 1.25. Okay, so we say 75 minus mu over sigma is 1.25. Now, so when you multiply over, this is now 1.25 sigma. We just have to solve these two equations simultaneously. So take equation 2 minus equation 1. 75 minus 50 is 25. Minus mu, minus mu, minus mu, cancel out. Now your 1.25, you need to minus 1.25 minus a plus 1.876. I got 3.126. Yeah, 3.126 sigma. Okay, then just divide them. 25 divided by this answer, 7.997. You round off is 8. So the marking scheme also give 8 as the answer. Yeah, this one is to the nearest integer. However, we are finding variance, not sigma. But well, first we sub inside equation number 2. 75 minus mu equals 1.25 times 8. Let's find out our mu. Take 75 minus 1.25 times 8. I got 65. Mu is 65, right? And your standard variance is now 8 squared, which is 64. Okay, I got my mu and I got my standard variance, not standard deviation. All right. Okay. Now, the next part, part B, this is the part that is a little bit, I would say, wrong. All right. Okay, if you read the question, I see. So here the school intend to give award based on 3 categories, which are the Platinum Award, Silver Award, and Bronze Award. Yeah. So these are the table shows the 3 categories according to specific range of average mark in percentages. In percentage. So you get bronze if you get more than 65 for your average mark. Silver more than 80, platinum more than 90. Okay, so find the probability of student not getting any award. So here's the controversial part, because you will not get any award by right when you get less than 65 marks. See, when we say average mark, right, you take your BM, you take your English, you take your science, your maths, and so on, you add up. Should you have decimal for your average mark? Answer is yes, right? So if we say that you will only get this award if you get above 65, greater equals 65, you will not get any award if you get less than 65, right? So that means we have to standardize it to x minus mu. Since my mu just now, guys, my mu is also 65. So you divide by your standard deviation, which is 8. This is PZ less than 0. Less than 0 means what? How many percent? Here, right? 0.5, right? So the probability is just 0.5. Now, however, the marking scheme gives this answer. They say less than 65 means we take less equals to 64. Now, here's the thing that something that's a bit off from your syllabus. Okay, I want you to know when you have 65, okay, 65 is in the middle, 64 is here. When we say less equals 64, that means you're taking this area, right? So what happened to this area in between? Do we just ignore it? We can't, right? So for those who get 65 and above, yeah, it's here. Less than 64, in normal distribution, less than 64 is, and less equals 64 is actually the same. So you're taking this area here. So here's the problem. What happened to the area in between? Right? Yeah. Okay. Actually, there's one cure for it, right? In higher level studies, higher level, when I teach A-level maths, we use what we call a continuity correction. So if you have 64.5, we need to enlarge this bar. We say, okay, this bar, we need to take 64.5 because it does include, if this is 64, right, we have to take from 64.5 onwards, right? So if it's 65, we have to start reading from 64.4 onwards. We cannot just leave a gap in between. There shouldn't be having any gap, right? Otherwise, your total probability is not going to be 1, right? So just so you know, if you go and check the marking scheme, right, for SBP paper, they use less equals to 64, which I think is incorrect, right? Because if you take less than 64, that means between 64 and 65, they don't get award, right? They don't get award, right? And then they're in no man's land, right? You cannot take like, oh, 64 here, 65 here. Okay, so this one didn't get award. This one got award. How about these people, right? What's the question? Question mark, right? Right. Now, if you say that the average score is rounded off to the nearest integer, then you have to take a bar here. You should take 64.5. And this one will be 64.5 onwards will receive award. 64.5 or less will not receive award, right? So just so you know, so I would say in this case, the correct answer should be 0.5, right? Not we don't take 64 and less, right? Okay, and since average marks can have decimal, so we should take less than 64. And always remember, in normal distribution, there is no difference between less equals 64 and 64. Less equals 65 and 65. Because area for one thin line, if it's 65 here, area for one thin line is just 0. So it's either less or more, equals is just 0. Okay. All right. So the second one, right? Well, if you go in, by the way, if you go and do x less than equals 64, then when you standardize, is that just so you know, 64 minus 65 over 8. Yeah, and in this case, if you don't put equals, it's the same thing. This is z less than. Just so you know, this one I would get, okay, I'll just count for you, 1 over 8, 0.125. You use a mathematical table or your calculator. I like to use calculator, it's a lot faster. Shift, first of all, you need to put shift mode. If you're using this calculator, shift mode press, wait, mode first, go to stats, all right, press AC, shift, stats, 5 for distribution. For upper tail, we put 3, yeah, this is 1.25, sorry, 0.125, yeah, your area is 0.4503. By the way, less than 0.125 is the same as more than 0.125. So yeah, we flip it over 0.4503. Yeah, it's big difference, like big answer. There's a big gap between 0.5 and 0.4503. Okay, second one. Number of students who receive silver award. Okay, silver award means you get 80 up to 90. So we can write like this. To get silver, you get 80 up to 90. Doesn't include 90. But it doesn't matter actually for a normal distribution because it's, remember, whether it's greater equals or greater is the same. Yeah, because area 139 at 80 is just 0. So we should standardize this. Minus 65 divided by 8. This will be 90 minus 65 divided by 8. All right, so this will be, I'll show you here. Okay, 80 minus 65, 15, divide by 65, divide by 8. There you go, 1.875. And 90 minus 65 divided by 8 is now 2.875. Sorry, it's not 2. I just changed it to 90. There you go, 3.125. So the area in between, in this case, both are on the right-hand side, 1.875, 3.125, right? This is your area in between. Okay. And we know this will be z more than 1.875 minus z more than 3.125. Okay, take the area in between. If you're using this calculator, shift 1 for stats, 5, 3 for R, 1.875. I got 0.0304. 0.0304, right? Then you probably want to use more decimal point. Take one more. 0, okay, 0.0 is 0. It doesn't matter, right? This one, 3.125, just change it to 3.125. Okay, this is a very small value. I shift ENG twice to convert to decimal, 0.000889. Yeah, 0.000889. Okay, so I'm going to take 0.0304 minus this answer. If you just write down this, you should get 0.02951. 0.02951. Yeah. Okay. Very, very small value. Okay. However, if you use this is just a probability. We're not done yet. We need to find the number of students who receive a silver award. Okay. So number of students who receive silver award, I'll just write number. Yeah. Is the probability multiplied by total. My total is 255. Yeah, you go back to the earlier part, 255 students. Okay, so take this answer, multiply by 255. I'll get 7.5, right? 7.525. 7.525. Okay, so here's the thing. Okay, do you take 7 or do you take 8? Here's the interesting thing. So answer is we round off to 8 students, right? We take the nearest integer. Why? Okay, I hope you understand this. These are the number probability, right? So if you have, imagine student who get silver is around 7.5 to 5. Okay, maybe that just for comparison. Let's say student who get platinum is 1.48, 1.4. This is 2.5, right? This would be 7.5. Okay, so question is, do you round this down to 7 or do you round it up to 8? So you cannot say, oh, this one I round out to 7. This one I also round out to 1. Then what happened to the extra 1%? It go missing, right? So that's the thing. We round off to the nearest integer, like how we do normal rounding off. So if you get 7.5 to 5, you round to 8. So that means in this case, you round this off to 8. And in this case, you round this down to 1. So that's a way to do it. You can't say that it's 7.5. I'm not a full person. So it's not a complete person. So I take 7 people. No. Yeah, we round up. We round to the nearest integer. Okay, I want to clarify this again. Your marking scheme doesn't use this because they take they say 80 and above, right? So they take 80 up to 89. So they take 80 up to 89. Now remember I said earlier, if you do that, that means the 89 is here, the 90 is here. There's a gap of probability of people who don't get silver, they don't get gold, they're stuck there. All right, so we can't do that, right? Because number one is average. If we don't take, when we say the average mark is rounded up to the nearest integer, then we have to extend this to 89.9. That means we have to take 89.9 up to 89.9, right? Okay, just so you know, just to clarify to you. Okay, moving on, question number 11. This is a circular measure question. Okay, Form 5, Chapter 1. So here, diagram show a triangular card ABC made by Serena. She draws a circle with center O inside the equilateral triangle. All sides of the triangle are tangent to the circle. Calculate the radius of the circle. Okay, so maybe I just redraw it, make it easier to see. Draw a bit bigger. You can see a triangle here. Now, when the line is a tangent, means it's perpendicular here. And since this is equilateral, so this angle is 60. When you cut in the middle, so this angle should be 30, right? And this is your B, this is your O. Maybe you want to call this N or M, yeah, up to you. So this length of the side, they are 24 cm. So that means the whole thing is 24. Length of side of this triangle 24, half of it, this will be 12. 12. So I put a 12 here, and I'm supposed to find the radius. Okay, the radius, I'm going to call it R, so we can use tangent here. Tangent 30, this is part A, is R over 12. Okay, use your calculator. Change your calculator to degree mode. This is degree. All right. Okay, and tangent 30 is, you can write set 3 over 3. You can change the decimal. Doesn't matter. You times 12. You should get 4 set 3 or 6.928. Yeah. So your radius R is 6.928. Okay. First part done. Second part, area of the shaded region. Okay. If you can see here, your shaded region actually, if you join together, there are actually 4 parts here, and they actually consist of a triangle. Then you subtract your sector, right, to get this shaded region. All right, but I have 4 of them. There are 4 equal parts. So basically, we just take area triangle minus area sector, then you times 4. Now, if this is 30, this sector here should be 60, right? 60. So for me, I'll take the area as 4 times of area triangle, half times base. My base is 12. Height, I'll take 6.928. Then I minus area sector, half R squared, 6.928 theta. My theta is 60. I convert to radian, multiply by pi over 180. But remember to use 3.142. Your pi is always 3.142 when you type in your calculator. Okay, so let me show you here. We take 4 times, open bracket, half your radius. The base is 12. The height is your radius, 6.928. All right, then you minus half 6.928 square. Your theta is 60 divided by 180. We can cancel. We can write this as 1 over 3, pi over 3. So your pi is 3.142 over 3. Yep, remember the closure bracket. There you go, 65.73. Yeah, 65.73. Now, you might get a slightly different answer if some student, they say, oh, I substitute my pi over 3 first, and I take 3.142 divided by 3. Then I round off. This one is 1.047. It's actually 4733333. You round out to 1.047. Then you sub inside. Then you realize your answer will be slightly different, which is okay. In fact, the marking scheme uses this, right? Now, personally, for me, I like to use them as accurate as possible. So I use pi divided by 3. Yeah. Okay. So last part. She said that the remaining ribbon, if Serena has 1 meter ribbon to be placed around the shaded part of the card, you put a ribbon here, you put a ribbon here, you put a ribbon here, put a ribbon here. All right. So basically, you're talking about perimeter. All right. Now you notice that if this is 12, this is 12, this is 12. So the 4 parts here are all 12. 1, 12, 2, 12, 3, 12, 4, 12. I just have to add this curved surface. I mean, the length of this arc. Okay. Now, we know these are all 60. So there are 460 here, 160, 260, 360, 460. That gives us 240. So I need to find the perimeter. Your perimeter consists of 4 times 12 plus r, radius is 6.928. Your theta is 240 times pi over 180. Yeah, you can write this as 4 over 3 pi. Okay, so I'm going to type in a calculator. 4 times 12 is 48. 6.928 times 4 over 3. Remember to use 3.142 for your pi. I got 77.02. Okay, but this is not what we want. We want the remaining ribbon. She has 1 meter of ribbon. So what is the remaining remainder, we say. So we take total 1 meter is 100 cm minus 77.02. I got 22.98 cm. Yeah, the length of the remaining part is 22.98. Okay, this is section C, question 12. This is solution triangle form for chapter 9. So, okay, you're given a triangle like this. You're supposed to calculate angle ACB. Okay, angle ACB. ACB is over here. So let's start by using sine rule. Now, we use sine rule when you have a pair of angle corresponding side, right, over here, and another pair with the missing information. In this case, the missing value is your angle ACB. So we're going to start off by writing sine angle ACB divide by 4.24 equals to sine 45 divide by 3.61. Okay, calculator. Sine 45 divide by 3.61 multiply by 4.24. Remember to use your calculator in degree mode, because if you use radian mode, then whole thing will be different. All right, so this is 0.8305. You shift sign, answer equals 56.15. Yeah, your angle is 56.15. ACB 56.15. Okay, that is Roman 1. Okay, Roman 2. The shortest, the length of AD. Okay, now that if I know this length, right, is 56.15. The angle next to it is angle ACD, and it's 180 minus 56.15. I got 123.85. Yeah, 123.85. Okay, so I want to find the opposite length, which is AD. So we use cosine rule here. AD square is 3 square plus 3.61 square to 3.61 cos angle in between. Okay, calculator, 3 square plus 3.61 square minus 2 times 3 times 3.61 times cos 123.85. Okay, whatever I get, square root, answer equals 5.839. Yeah, your AD is 5.839. Okay, third, the shortest distance from line point D to straight line AE. Okay, Shortest distance is a perpendicular distance from a point to a line. You can call this N if you like. Okay, that's the shortest distance. So here they gave us the area of triangle. Area of triangle ADE is 14.5. So we already know the area of this triangle. Okay, so it's very simple. We already know the length of the base. Now you don't have to use solution triangle. A Form 1 student would be able to do this. It's basically half times base times height. Yeah, your height, or you can put it dn, that is your shortest distance. This area is 14.5. Now let's take 14.5 times 2, divide 9.15. I got this 3.169. Your dn is 3.169. Okay? All right, that is part B. Okay, B Room 1. Sketch a triangle A prime C prime D, which has different shape from the triangle ACD, such that CD equals C prime D, AD equals AD prime, right? And CAD equals C prime AD. Okay, first of all, my length that I need to maintain, okay, let's rub this off first. The length that I need to maintain is CD. I need to maintain CD here. I need to maintain AD here. All right, and I need to maintain CAD, this angle. Now remember the idea of ambiguity. Ambiguous case happens when the opposite side to a given angle, this angle is given, the opposite length is CD, is shorter than another given side. So 3 cm is actually shorter than AD. Yeah, we know AD from the earlier part, right? Now you don't even have to calculate because we can see from the diagram it's 5.839. This AD is longer than CD. So ambiguous case happens. There is another triangle we can draw. Now, the second thing you need to know is that the two given length, AD and CD, they both meet at D. D is like a hinge, so you got to flip either outside or flip inside. So imagine you have a compass with a sharp end placed on D. Your pencil, yeah, you draw here, you flip it like that. Now, notice we can't flip inside and form a second triangle. So what we need to do is to go out and we're going to flip, extend the line AC. Now you notice there's another triangle I can form. Sorry, a bit ugly looking here, such that this is your C prime here. And C prime and CD are the same length. This is also 3 cm. Yeah. So the second triangle that we can draw is triangle ADC. Yeah. Let me highlight for you. The whole triangle we draw is this one. 1, 2, 3. You're going to flip it out so that I maintain this length, I maintain this length, and I maintain this angle. Okay. So we need to draw a full version. Okay, I better draw nicely. Okay, use a different color. Okay, my triangle should look like this. Okay, first line. Second line will be starting from here. Okay, over here. Okay, and the third one, oops. The third side will be from here to here. Okay, it's a bit off. See, I can adjust it. Yeah, around there. Okay, so there you go. This is your triangle A, C prime D. Okay, the one with prime is C. Okay, and if you to label this C is over here, it's actually not necessary for you to label. It's this the C is over here, original C. Okay, we are supposed to sketch a triangle and then calculate the area of DC, DC and C prime. That means the triangle inside here. Okay, we know this is 3 cm. We know this is 3 cm. Now, earlier we know this is 56.14. That means this is, they're intersecting, right? This is 56.14. This side here, 56.14. In fact, this, since they're equal length, the isosceles, this is also 56.14. I need to find this angle, right? So to calculate the area, I need to find CDC prime, which is 180 minus 56.15 times 2. Okay, calculator. 180 minus 56.15 times 2. I got 67.7. Okay, so I know this angle, 67.7. So your area will be half A B sine C. Okay, 67.70. You're only finding the small area here. So use your calculator. Half your AB is 3 times 3 times sine 67.7. There you go, 4.163. 4.163. Yep, that is my answer. Okay, question number 13. This is index number from 4 chapter 10. Diagram shows the price indices of 3 types of ingredient PQR used in manufacturing a tapioca chip. So you are finding the first part, the price index of ingredient P in year 21 based on year 2019. Okay, so here you notice there are 3 years involved here. If you look at just focus on P, right? We have year 2016, year 2019, and year 2021. So for P, this is item P, 16 to 19, it increases by 12%, we're at 112. And then 16 to 21, it increases by 40%, we're at 140. And we want to find this index. We want to find year price index for 21 based on 2019. So I like to use this, we call it a simplified chain rule. We take the 2 consecutive indices times together, divide by 100. Yeah, it must equals to the overall increment, which is 140. So basically we take 140, you times 100, divide 112, I got 125. Yeah, so this index is from 2019 to 2021, and the change or the increase is the index is 125. Okay, B. The price of ingredient Q in 2016 is 5 ringgit, and the price in 2021 is 6 ringgit 35 cents. So we got prices for 2016-21, which is this 2 year, right? It will help me to find my A, right? So we know A is the price index, or can I say I 1621. Now, how you write this is up to you, because some teacher write 21/16. It's the same. I have to write base followed by current. You can write base slash you can write current slash base. Base is 16, current is 21, P21 over P16 times 100. So this is your A. Price in the year 21 is 6 ringgit 35 cent. Price in the year 2016 is 5 ringgit. You multiply by 100. Okay, 6.35 divided by 5 times 100. Guys, I got 127. Okay, then I want to find the price of ingredient Q in the year 2019. Now, to use that, I need to go back to this and use this because I'm finding the price in 2019. Price in 2016, I already have it. Let me write down the formula. 1619, this is P19, P16 times 100. This one is 110. P19, I don't know. P16 is 5 ringgit. All right, basically 5 ringgit times 1.1 over 100. You can say 5 ringgit times 1.1 over 100 is 1.1 is 5 ringgit and 50 cent. Okay, right, that's part A and part B. Okay, moving on to part C. We are finding they say the composite index, right? Composite index for the cost of making the chips is 1 to 5.5. The ratio is 5, 3, and 12. Find the value B. Okay, this is 16 based on 19 based on 16. So I think it's better for me to do it over here because I can show you from the table, right? This is part C. We know the ratio. Let me check again. The ratio is 5, 3, 12. Composite index is 1 to 5.5. Okay, 5, 3, 12. Composite index is 1 to 5.5. And this is year 2019 based on 16. 19 based on 16 means I have to use this one. Okay, I already know my B, right? My B, okay, I don't know my B. I'm finding B, right? Let's take the index 112 multiply with a weightage 5, then 110 multiply by 3. Let's take B multiply by your weightage 12, total weightage is 5 plus 3 plus 12. This result is 125.5. Okay, let's count. Let's take 112 times 5. Okay. And then you plus with 110 times 3. This will give us 890. 890 plus 12b. This one is 20. Up to you. You can write more step if you want. 125.5. This is 20, right? Okay, so let's take 20 times 125.5. Okay. In fact, you can just minus directly. Yeah, you minus 180. Minus times over minus 890. Yeah, I just minus 890. Okay, I do one by one up to here. 12b is 1620. 12b is 1620. Whatever I get, I divide by 12. 135. My b is 135. Okay. All right. It's not difficult. Okay, I still got one more part to go. The last part. Okay. Now they say find the price of packet tapioca chips in 2016 if the corresponding price in 2019 is 25 ringgit and 50 cent. Okay, well, I can continue here, right? Hope you're okay with that. So now we know that the overall increase from 16 to 19 is already given 125.5, right? So if the ingredient goes up in price, I mean, the price increases, so the selling price of a packet of tapioca chips is also going to increase at the same rate. So this is a basic assumption that they actually made. That is, when your cost goes up, right, your selling price must go up accordingly. But actually, in matter of fact, this is not true because cost plus profit equals to selling price. Sometimes you may have cost that goes up, your selling price cannot go up, because if you sell a higher price, then your competitor may actually profit for it, right? Your customer wouldn't buy from you, right? So you maintain a selling price, then your profit has to go down, right? Or sometimes your profit may actually go up, then the selling price go up even higher, right? So we are making an assumption that the cost and the selling price is increasing at the same rate. Okay, so now your price, your composite index, we already have earlier, is 125.5. So you are using this. Yeah, this is your overall increment in your ingredient. Yeah, ingredient has gone up by 25.5%. So your selling price naturally increase at the same rate. Again, is an assumption. So the price in 2019 is 25 ringgit 60 cent. Price in 2016, I don't know. I times with 100. I got 125.5. So to find this, I'll take 25. Yeah, 25.6. I times 100. I divide by 125.5. My price is now 20 ringgit and 40 cent, around of 20 ringgit and 40 cent. Okay. Okay, moving on. This is question 14. It is Form 5, Chapter 7, Linear Programming. Okay, so first of all, we need to form three inequalities. They say Ida wants to buy a size B, A and B painting to be exhibited in the art gallery. The price of size A, size B are 300 and 200 ringgit respectively. Ida buys X unit of size A, Y unit of size B. The purchase is based on the following constraint. The total allocation is 9,000. Okay, so the first inequality is this. If you buy size A at the price of 300 each, if you bought X unit of it, so it's 300 times X. And size B is 200 ringgit each. If you buy Y unit of it, is 200 ringgit times Y. And this sum must not be greater than 9,000. Allocation means you can only spend maximum 9,000. Okay, actually you can stop here, but for me, when you want to draw a graph, right, it's easier to deal with a smaller number. So I'm going to divide by 100. So I will get 3x plus 2y less equals to 90. So this is my first inequality. Okay, second one, the total number of size A and B must be more than 15. Size A is X, size B is Y. More than 15 means greater than 15. Okay, third inequality. The number of size B, which is Y, must exceed or equal to the size A painting. Exceed or equals means greater equals size A is X, so Y greater equals X. All right. Okay, first three, no problem. Next part. Form 3 mathematical model other than x greater equals 0, y is equal to satisfy. So actually, I answer part A. Next one. Using the scale of 2 cm to 5 unit of both axes, construct and shade the region. Okay, we will need a table value. So I'm going to draw table values on the right here. So the first one is 3x plus 2y equals 90. So to draw a straight line, I'd like to use x equals 0. When I sub 0 inside, mentally I put 0 inside, 90 divided 2, my y is 45. I sub y with 0, 90 divided by 3, my x is 30. Okay, the question already say 2 cm to 5 unit both axes. So let's move down a little bit. Okay. So this part here is 0, 5, 10, 15, 20, 25, 30. Yeah, I don't know whether I would exceed this, but I think 30 should be 35. 30, 35 is enough. 5, 10, 15, 20, 25, 30, 35, 40, 45. I think 45 should be enough. Right, this is my y. Okay, so the first one you can see 0, 45, 30, 0. Let me use a line here. 30 is here. Okay. I think my line is okay. So this is 3x plus 2y equals to 90. Okay, the second one, I'm going to use x plus y equals to 15. So table values, I start with x equals 0, y is 15, y equals 0, x is also 15. So it's 15, 15. Since this is a dotted line, this is not a straight line. It is a dotted line. So you can use here. I will have to change my line. Yeah. I wonder whether I can change the property of the line. No, I can only do this. Okay, maybe I just change it to dotted line here. Then I have to erase it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Around here. So take the dotted line here, the whole dotted line. Yeah, I can't take the whole dotted line. Okay, delete it. Okay, so this is your x plus y equals to 15. Okay, so the third graph I have to draw is y equals x. Yeah, y equals x. If I start off with 0, your y also 0. You're going to take a second point. Huh? Maybe we can take any point, 20, 20. You can put 30, 30, up to you. 20, 20. When x is 20, y is also 20. Okay, so use a point here, starting from here, 20, 20 should be this point. Yep, passes through 20, 20 here. So this is y equals x. Okay, so we're going to shade the region. So they say, first of all, your x, 3x plus y is less equals 90. So it's below this line. Yeah. Number 2, it must be above x plus y equals to 15. Yeah. Since it's greater, greater is a dotted line, not a solid line. Third one, y greater equals x. So it's here. So your region of feasible solution is here. Okay. Yep. So normally we use symbol R to represent this. Okay. I'm done with this. Okay. Let's move on to the second part. Now, the second part is part C here. Find the range of number of size A painting. Size A is X. If 10 units size B are bought, size B is Y. So Y is 10. What is your X? Okay. We can draw dotted line here. This is your X and 10. So it's between 5 and 10. But take note that it doesn't include 5. Yeah, it doesn't include 5. It's between 5 and 10. It doesn't include 5. So you can either, because this number of painting is a whole number, it's a discrete number, right? So you can either say between 5 and 10, or you say 6 and 10. Yeah, because it doesn't include 5. Yeah, it can be 6 or more. Okay, so both are also fine. And lastly, the amount saving obtained by Ida if he buys at the maximum number of size A, B painting given a discount of 20 ringgit and 10 ringgit. Okay, so this is where we have to form what we call an objective function. Your objective function represents your discount. So maybe you just call it K, and size A painting, you get 20 ringgit discount. So you buy X of it. Size B, you get 10 ringgit discount. You buy Y of it. So let's make Y as a subject, and Y equals to minus 20x plus K. So Y is minus 20 divided by 10 is minus 2x plus K over 10. Now I like to do it this way because some teachers say, oh, put a random number for K, like K 200, 100. Well, you can, but sometimes it's a bit hard because we don't know how to estimate this. I like to change it to Y equals mx plus C so that I know my objective function that I need to draw is has a gradient of -2. What we want is to find the maximum K. Maximum K is affected by a y-intercept. The bigger the y-intercept, the bigger the K value. So let's draw a line with a gradient -2, right, on your graph. Okay, gradient -2 is very easy. We look at your ratio of y over x. It must be 2 to 1. You can draw any length at any side. I like to use maybe 20-10. Okay, so for example, this ratio must be 20 to 10. You see that, right? So y-intercept is 20, x-intercept is 10. Okay, and normally we use dotted line for this. So you don't want to use solid line, is fine. Yeah, this is your dotted line. Okay, so this is your objective function. 2x plus, 20x plus 10y equals to K. So you're going to take this line and you just have to slide it up. We want a maximum discount, right? The maximum discount can happen. Okay, I need to select the whole line. Yeah, sorry. Oh, okay. It can happen anywhere. You can put it here, but this one is not going to give us the biggest y-intercept. The biggest y-intercept happens actually here, right? At this point, right? So just have to identify which point gives us the largest y-intercept. Now, you don't have to draw all the way up, but we just have to identify the coordinate of a point, right? You can see from here, you want to extend all the way up, but it's not necessary. What we want is we can see this line definitely give us the largest y-intercept. And the coordinate, sorry, I had to zoom in. It looks like 18. Okay, sometimes it's not very accurate. It's at this point here. It looks like your x is 18, your y is also 18, right? So this point gives us the largest y-intercept, therefore the largest K value. Okay, let's move back to this, right? So we say that your K, this is Roman 2, your K is maximum at 18, 18. To find the maximum value of K, we put 18 inside and another 18 inside. Yeah? So it's 30 times 18. So 20 times 18, 10 times 18 is basically 30 times 18. Okay, that will give us 540. So your maximum saving is 540. Okay, now last question, question 15 is kinematic linear motion from 5 chapter 8. So diagram 8 shows the position direction of motion of particle A that move along straight line. A straight line passes through fixed point O. So the velocity of A is given by this. Find the velocity when it passes through O for the first time. Okay, now when you start, the clock is at point O. So when you start, T is 0. We replace T with 0 here. Velocity of A is just 6 meters per second. Okay, next, find the time when the particle A changes direction. Now, particle will change direction when the velocity is 0. Okay, so let's take 6 plus 4t minus 2t squared. Let it be 0. Now, I need to solve this. It's a quadratic equation, so let's divide by -2. T squared minus 2t. 6 divided minus 2 is -3. Let us double bracket factorize them. T t 3, 1 minus plus. Your t is either -1 or 3. Now, we know t is always more than 0. T can't be negative. So we take t equals to 3 seconds. Okay, next. Find the distance traveled by particle A in the 6 second. Okay, distance traveled in the n second. I hope you know this. Distance traveled in the first second is S0 to S1. Or should I say that today, if I were to sketch this graph, it probably look like this, because we already know your y-intercept, your x-intercept is -1 and 3. So distance traveled in the first second is from 0 to 1. Yeah, first second. Second is from 1 to 2. Third second is 2 to 3. Fourth second is 3 to 4. Fifth second is 4 to 5. Sixth second is 5 to 6. Okay, now you don't have to draw this. You don't have to draw this. Okay, just so you know, velocity, this is velocity time graph, V versus T. So you can use definite integral. Now, some students may go and integrate velocity to find displacement, then sub in the displacement function. You can do that. That means you can do S6 minus S5 to find the distance in between. But when I do my sketch, I can see it's below the x-axis, the t-axis. That means your area is going to be negative. So my distance travel, I either put a modulus or I put a negative in front. I'm going to integrate from 5 to 6. My velocity function is 6 plus 4t minus 2t squared. Okay, as I integrate this, I got 6t plus 2t squared, 2t cubed over 3 from 5 to 6. Okay, let's put 6 inside. This is 6 times 6. 6 squared is 36. 6 cubed is 216 minus 6 times 5. 5 squared is 25. 5 cubed is 125. Okay, use your calculator. You can count manually, or you can even use your calculator one shot. Okay, I'll show you one by one. This is 6 times 6, 36. 6 times 2, 72. This is 2 minus 203. Minus 2 over 3 times 215. And then you minus, this will be 6 times 3 is 30. 2 times 5 is 50. This is 2 times 125 is 250 over 3. There you go. I got 98 over 3 negative. So that means 32, 203. Now you will get negative because it is below the x-axis, the t-axis. So we just put a negative in front to make it positive. So your distance is 32, 2 over 3. Now, even if you don't know it's negative, just integrate. Then you get the negative answer. Then we just say distance is positive 32 over 33. Yeah, because distance is always positive. All right, let's move on with the last part B. Now, a particle B starts moving at the same time as particle A. Initial velocity of B is 5. Acceleration is given by this. Okay, so first we want to express velocity function of particle B in terms of t. Now, remember, when you differentiate velocity, you get acceleration, right? When you integrate acceleration, you get integrate, you get velocity. So to find velocity from acceleration function, yeah, this is velocity of B. We integrate 9 minus 4t dt. So this is 9t minus 4t squared divided by 2. I write 2t squared plus c. You need to find the c value. We know initially when t is 0, your velocity is 5. So you put 5 inside. T is 0. Your c is also 5. So my velocity function is 9t minus 2t squared plus 5. Okay, so I've got my velocity function for B. Okay, then find velocity of the particle B during the, when, I shouldn't say during, when the velocity of A is maximum. Okay, let's go back to your velocity of A. We already have the velocity function here. 6 plus 4t minus 2t squared. Maybe I write it down. Yeah, velocity of A is 6 plus 4t minus 2t squared. So velocity of A is maximum. A is maximum when your acceleration is 0. So yeah, remember you reach a maximum velocity here let's say when the gradient of your velocity time graph, which is acceleration, is 0. So let's differentiate this. Differentiate 6, you get 0. Differentiate 40, I get 4. Differentiate this, I get 2 times 2, which is 4t. Let your acceleration be 0. So 4t is now 4t is 1. Okay, I'm finding what? I'm finding the velocity of b when a is maximum. That means it happens when t is 1. So take 1 and substitute inside here. So it's 9 times 1 minus 2 times 1 plus 5. 9 minus 2 is 7. 7 plus 5 is 12 meter per second. All right, I am done with this paper. All right, so thank you very much for watching. Hope you learned a lot in the process. Right, I'll see you guys in the next video. Thank you.